Welcome student. Today I am going to discuss a new topic, dynamic memory allocation. In the previous lecture I have discussed about preprocessor directive, preprocessor, how it is work, and what are the preprocessor directives are available in C programming. We had discussed about the has defined, that is macro substitution. We have discussed about the has include, that means find inclusion, and we have also discussed about some conditional preprocessor directory. So in this lecture I mainly concentrate on dynamic memory allocation. We are already familiar with memory allocation, right? In memory allocation may broadly classified as a static allocation and dynamic allocation. Static allocation means size of the memory may be required for the calculation that must be declared before loading and executing the program. In our example array, we have seen that if I want to declare the array of size 50, then initially we have to declare int arr, name of the array, within third bracket we have to give the size of the array, right. So that is a static declaration. And in case of dynamic allocation, the required memory size is allocated while program is executing. So there are so many advantages. Mainly there are two important advantages. First, dynamic memory allocation has advantage over static allocation in that sense that in case of array, suppose I want to declare an array whose size is 1000, maybe I have declared, but I am not using the whole array. That means, for example, I am just using 100 element, I have just stored 100 element in my array. Okay. So rest of the 900 place for this element will be wasted or ideal. Okay. So in the rest of the memory space is wasted, so we cannot use during the program execution. Secondly, suppose I want to change the size of an array in my program, then it must be re-edited the program, right. So re-edited the program. In the dynamic memory allocation, there is no such problem, as it is allocate the required memory during the execution of a program. Okay. So these two advantages very useful in our programming concept, because we are not going to waste any memory during the execution of a program. We can reuse this memory as per our requirement. We can allocate this memory during our runtime. So that are the advantage over the static allocation. In dynamic memory allocation, there are so many memory management function are available, right, to solve the modification during the execution of a program, like array data structure or any other in case of complex data structure where we need to allocate our memory during the runtime, use some function. So these are the most popular function. We have only alloc, malloc, calloc and realloc. These three function is used to allocate a block of memory in our heap area, right. And therefore this four library function, and we use to deallocate the memory, we use another function that is called free. Free is used to deallocate the block of memory. These four functions are in a header file that is called stdlib.h. lib.h header file, and we also use alloc.h for allocation purpose. Okay. So, let me consider the first one. First talk about the malloc. What does it mean? Why it is used? Malloc is a most frequently used dynamic memory allocation function. By the syntax of this memory allocation function, first we have to write the malloc. Malloc stands for memory allocation, which is used frequently in our dynamic memory collection program. So, we have to write malloc malloc, then we have to specify some size underscore t, then size. This is my actual function. We pass an argument, that is size. How many bytes are required? A single large block of memory with specified size, then we go for the malloc function. Here we know that this function is size can never be a negative, it may be always positive. You can think as a unsigned integer, unsigned integer. Unsigned integer you can think, and size is how many bytes you are required. For example, if I want to allocate memory for 4 byte, so I will write in this way, but it is not a good choice to write the program in such a way. I will discuss in a minute little bit. So, what is the return type of this function? The return type of this function is void pointer. Okay. So, this is my function. When you call this function, I will pass an argument. What is the argument here? I have to use the how many byte required for the particular block. We have to mention here. This is the malloc function, and return type of this function is void. Okay. So, if I write in this way, int, or if I write void, because it is return the void pointer vector p equal to malloc 4. Now, is it valid? Of course, it is valid, but let me see the pictorial representation. If I think as a memory in our computer memory in heap area, let's consider each of the block is 1 byte, right? 1 byte. For example, this is the size block address is 200 and next byte is 201. I am thinking as a byte, 1 byte. So, if I write malloc 4, so that means 4 block of memory, consecutive memory will be allocated, 200, 201, 202 and 203, and this pointer will point to the first block of memory address, right. So, 4 byte of memory will be allocated, and the return type pointer which will point to the first block of memory if it is successful, or if it is not successful it will return 0. So, that you can understand that the function attempt to get a block of memory is fail. Now, if I consider, if I want to declare some value, like if I want to assign some value to this location, what will happen? Suppose I want to assign some value to this location, because I have already mentioned that it will return the first block of memory address. So, if I write star p equal to, is it valid? No, it is not a valid. Why? Because it is written a void pointer. So, if I want to use or allocate some memory, some value to this space to assign some value, to this first address, we need to typecast the return type pointer, and it means that I want to say that what kind of value is going to hold or assign in this location. So if I completely write this syntax, we will say that, so I have to write like suppose I want to store integer, and so I have to write int star p is a pointer, so integer pointer. So then we have to need whatever the return type that I have to typecast into integer. Then I have to write malloc. Then if that line is also okay, but if it is not a good practice to write in this way to specify the number of block in computer memory, because that size of primitive data type or other data type, complex data type, which is basically depend on compiler, how many byte will be allocated. So we better to use a sizeof function. Then suppose I want to allocate the memory for one integer. So I already know that it will take 4 bytes. So integer in my computer, it will take 4 byte. So sizeof function is basically used to indicate that it will size of 1 unit, right? Size of 1 unit. Size of 1 unit, right? So 1 unit of integer will be allocated. What is the size of integer? No, 4 byte. So 4 byte will be allocated in this location, right? Suppose I want to allocate that for 3 integer, then we have to multiply with this number of element, that is number of element. So where how many byte will be allocated? So this is 4 into 3, that means 12 byte of memory, consecutive memory will be allocated, right? So 200 to 2011, 211, 12 byte of memory will be allocated. So in this way we can use the malloc function. So please remember that whenever we are use malloc stands for memory allocation. Wherever we are going to use the malloc function, we have to pass the argument how much byte is required, and I have to use also typecasting, what kind of value we are going to use in this sense. So we need it, because void pointer return type of the malloc function is a void pointer, and void pointer is a generic pointer, you cannot use in practically. So that's why we have to need to convert into a generic pointer so that we can understand it. So that's all about. Suppose I want to if I want to write the syntax in a complete way, so that is the syntax. Whatever the pointer I am going to return, this is my pointer. If the pointer is integer, I will write integer pointer, and then if I want to typecast into an integer, I can write in this way. Then malloc. Then if I want to allocate, for example, 100 element, so I can write in this way 100 into size of int. So now compare with the syntax. First I have to write pointer, ptr is a pointer. Then what I have done here, typecasting. Okay, so I can write cast type, what kind of variable I am going to task, cast type, then star, then malloc, then size, byte size, right? That is the syntax. This is the syntax, and you can think one of the example here. This is syntax. So malloc or memory allocation method in C used to dynamically allocate a single large block of memory with specified size, and it returned a pointer of type void, which can be cast into a pointer to any form. It may be integer, it may be character, whatever it is, we can may be typecast. So, that is Malloc function, right. And the next function is Calloc. Calloc is stands for contiguous allocation, or we can write contiguous allocation. Means here the return type is also a void pointer, and we also need to typecast. So, this is the syntax. So, we need to cast type. Let me cast type, then Calloc, then n, then element size. This is the syntax. Whenever we use the Malloc function, whatever the byte has been returned by this function or allocated by this Malloc function, the default value has not been initialized. But in case of it initialize each block with a default value 0. So, here Malloc function used to allocate the number of byte, and Calloc function used to allocate the number of block of memory in a specified type dynamically, right, and it initialize each block with a default value is 0. Here n stands for the Calloc function is useful for array and array like structure where the continuity of memory is required. Here we have used n comma element size. Please be concentrate on that point, that n is the how much byte. For let me take an example so that you can understand it clearly. So, I am writing for example ptr float star, then I have to write Calloc, then I have to write 25, then size of float, for example, right. So, this statement allocates continuous space in memory for how many element? 25 element, right. And what kind of element it is? Float type, and the size of float. So, here we have to declare number of element, n stand for number of element, and here size of each element. From this example we can understand the size of element, and from here 25 we can get the number of element, right. So, it means that Calloc function is used to allocate the contiguous memory, please Calloc or contiguous allocation, contiguous memory allocation, or we can say element by element basis, okay. So, I will allocate for 25 element in this example, I will allocate for 25 element, and this statement allocate contiguous memory location, that is the difference between the Calloc and Malloc function. Block of byte of memory, here block of memory, here in case of memory allocation of, if I use the Malloc, the default value will be a garbage value, but in case here the all initialize each of the block with default value is 0, right. And we use another function that is called realloc, or we can say reallocation. The syntax of this realloc function is, ptr, this is a pointer, and realloc, this is the name of the function, and this is the pointer as a first argument, and second one is new size. Let me explain all this line one by one. This method is used to dynamically change the memory allocation of the previously allocated memory. For example, in my if I use the memory Alloc function or Malloc function, by which we can allocate the memory, and after that if I want to modify some my previously allocated memory location, then we can go for the reallocation, right. In the other word, if the memory previously allocated with the help of Malloc or Alloc it is insufficient, then realloc can be used to dynamically reallocate the memory. Here the first syntax is ptr. Ptr is a pointer, right. Ptr is a pointer, and here the second syntax is new size. That means how many byte if I modify this. For example, if I the size of ptr is changed from 20 byte to 40 byte dynamically. So, here we use the new size. What is the new size for allocation? And where ptr is a reallocated with the new size of the specified memory. So, ptr is a pointer, we know that, and this pointer is reallocated with new size, new allocated size, and if space is insufficient, the allocation fail, then it will return a null pointer, right, it will return a null pointer. So, these are the three methods we use for a memory allocation. We use the memory allocation for Malloc, or we can go for the Alloc. Okay. But if I want to modify my previously allocated memory allocation either created by Malloc or Alloc, we can reallocate by using realloc function, where the new size I have to give as the two arguments. The second argument is the new size of allocation. So, realloc function is used to increase or decrease the size of the block of the heap memory to size specified by the new size. Right, and we have another function that is called free. Another function that is called free. Free function is used to deallocate the memory. Free function used to deallocate the memory. So, what does it mean actually? The free function used to free a portion of storage within the heap previously allocated memory location. It means that if I use, for example, free, and the syntax is we have to use the free then name of the pointer. For example, the name of the pointer is ptr. It means that the free method is used to dynamically reallocate the memory allocated using the function malloc, or it may be a calloc, is not deallocated on their own. Hence, the free method is used to whenever the dynamic memory allocation takes place. Okay. So, by using malloc or calloc, we cannot deallocate the memory. We use the free function. It helps to reduce the wastage of memory by freeing it. So, whenever it is not required, we have to just use the free function so that you can free this pointer to this memory location. And this pointer, the first argument is a pointer. That pointer is argument to the free is the starting address of the region which has been already allocated. And if I want to deallocate it. Okay. So, that means we just free this memory. Okay. So, that is all about the dynamic memory allocation. Here we have compared with what is the static allocation, what is dynamic allocation, what are the advantage of dynamic allocation over static allocation. Mainly we use reallocate the memory, we can use change the memory location during the execution of a program, we can change the size of the memory during the execution of a program. So, that is one of the important. Mostly in case of static array we have seen that we are facing many problems. Suppose I have assigned an array of size 100, but I am using 10 element, I have just used 10 place location in my array and 90 place I have not used. So, that means that portion of memory is not used, but wasted. So, to initialize the array in during runtime, it is basically it's the advantage. And suppose I have declared a array size is 10, but in future if I think that my size might be grow in 20 or 30 element I have to store. So, that means I have to redefine this program to overcome this situation. So, it is very helpful in case of dynamic memory allocation is always is helpful, and so that we can use the three method. One of the method is called Malloc function, we use the Calloc function, we also use the realloc function, and Malloc function used to allocate the byte of memory, and every time the in case of Malloc function or Calloc function the return type is a void pointer. So, we need to cast this void pointer according to our requirement. And one thing we have to remember that whenever we are passing argument to allocate the memory, the size, the how much byte is required is always a positive argument. So, we can think as a this variable is a unsigned integer, right, and this all about the allocation and the allocation, and if I want to reallocate, we use the reallocate function. And whenever we are using the Malloc function or Calloc function or realloc function, one thing we have to remember that we always which is the memory which is not used in practical, then we will go for the use of free function. So, we always use the free function along with the Malloc and Calloc function, so that we can dynamically free those memory which are not required by the program. So, we basically go for the free method. These three Malloc function, Calloc function, allocation, reallocation is belongs to header file std lib.h. We also use the alloc.h is for allocation. And in this next lecture, I will discuss about pointer, which is very important concept in our C programming, and the concept is very important in that sense. If I use the pointer, most of the time we will do a smart program in that sense that we know that pointer is a variable which can hold the address of another variable. So, if I must flexibility with the pointer, we can do our problem, solve our problem very easily. So, pointer is a very important concept, I will discuss in my next lecture. So, thank you.